GM everyone. Welcome to another workshop for the Infinite Space Bazaar. I'm your host, Josh from Celestia Labs. I work on the DevRel team, working with documentation and integrations and doing fun things like this. Today, I'm excited to welcome Ken from Polymer. And Ken, what do you do at Polymer?
I'm a technical growth manager at Polymer. I do a lot of DevRel stuff. I also help with like BD and our partnerships, a lot of different things. But yeah,
I
really
got a,
excited to be here. Thanks for having me.
yeah, you're welcome. I guess a better question too to like start things off is what is Polymer?
Yeah, Polymer is the interoperability hub of Ethereum. I'll go into this in the presentation, but essentially it brings IBC technology that's common and part of the Cosmos ecosystem to Ethereum L2s, and the vision is eventually expanded even beyond.
Awesome. And on that note, I'll give you the floor, and I'm excited to learn more.
Awesome, cool, yeah. Thanks, Josh. So yeah, I'll be monitoring the chat as this presentation goes on. I'll try to be answering questions like proactively, and then we'll open it up to questions at the end too, that we can have a discussion. But without further ado, yeah, I'll get right in. So as mentioned, technical growth manager at Polymer. My name is Ken Miyachi. I'll have my information at the end of the presentation if you'd like to reach out or contact me. So Polymer, as mentioned, is the interoperability hub of Ethereum. Right now it connects OP stack L2s, but the grand vision is to eventually connect other L2s such as Arbitrum, Scroll, etc., and then even beyond the Ethereum ecosystem to Cosmos chains and other chains throughout the entire Web3 ecosystem. So what does the interoperability hub mean? The term port city was coined by two members of the Cosmos ecosystem, Ethan Buckman and Sam Hart. And a port city is a clearinghouse for trade routes that connects different ports or entities to communicate with one another. So Polymer is the port city of Ethereum, which establishes trade routes both to Ethereum as well as external ecosystems. The example that I like to use is the port of Los Angeles. Los Angeles, right? The United States has a bunch of different trade laws, routes, etc. within itself, and you can think of that as kind of a whole ecosystem in itself. But then the port of Los Angeles is the largest in the U.S. and is a trade route, is the entry point to many other entities, cities throughout the world that then get transferred within the United States. And so the grand vision is to be like the port of Los Angeles, connect Ethereum to the rest of the Web3 ecosystem. Right now, we're specifically focused on OP stack L2s, and we'll slowly expand to other L2s and then the full Ethereum ecosystem. So going into Polymer's technology, how does Polymer do this? How does Polymer become the port city of Ethereum, or the interoperability hub of Ethereum? The two, I would say, core components of the technology are IBC transport and Ethereum settlement. So the Inter-Blockchain Communication Protocol, IBC protocol, is a transport communication protocol which is used in IBC, and this is what Polymer uses to connect all the different L2s in the Ethereum ecosystem. And what it does is it separates transport level execution from application level execution. So anything that you're using to transport or pass messages across chains is separate from the actual execution logic that is in your applications occurring in the rollups. The second kind of core component of Polymer's technology stack is Ethereum settlement. So Polymer, not only the IBC client, but Polymer itself is an OP stack rollup, and it uses Ethereum settlement to read the true state of both the rollups and itself to have a highly secure picture of both the state of the L2s and all of the transport and cross-chain communication that is going on between the different rollups. A little deeper dive into what Ethereum settlement and what that means and why it's important. Polymer extends the native Ethereum bridge. So all L2s, bridge information, communicate information to the Ethereum L1 through the native bridge. And Polymer utilizes that native bridge and extends it to implement their communication protocol. So if you see on this graph right here, on this diagram right here, what Polymer is doing to transport and pass messages from rollup A to rollup B, it's actually reading the state of the L1, reading rollup A's state to instantiate and initialize a communication that passes a message to rollup B. And this provides a much more enhanced security model over some other interoperability protocols because it's still utilizing the Ethereum L1 security model to secure message passing throughout the different rollups, just as any transactions on any individual L2 does as well. It still relies on Ethereum settlement for finality at the end of the day. So why does IBC matter? IBC matters for a couple different reasons. Maybe the first one is on the right-hand side. If you look at this was a tweet by, I believe, the IBC Foundation a couple of days ago. I thought it was a good and very simple visualization of why IBC is great. 0 exploits throughout their 4+ years of existence, or 3+ years of existence. That's super, super impressive. I think a lot of the hacks and security issues that have happened recently in Web3 overall, specifically even last year, was bridging protocols. A lot of bridges had a lot of exploits and security vulnerabilities that led to millions, if not billions of dollars of lost funds. And if you look at IBC, it's led to 0 exploits. So the technology is not only mature, but battle tested and proven to be extremely, extremely secure. Kind of what has gone into creating very 0 exploits and very strong security is this concept of acknowledgements. So in many kind of cross-chain communication protocols, yes, you send the message, you send the information or the data from chain A to chain B, or from an application on one chain to an application on another chain. But what IBC implements in their spec is this concept of acknowledgement. So for a full packet lifecycle to be successful, not only do you need to send the packet, but the destination needs to receive the packet and then send back an acknowledgement, really enhancing the overall security of the total message transport overall. So IBC is kind of a Cosmos invented technology. How does Polymer bring IBC to Ethereum? What Polymer has implemented and created is a concept called virtual IBC. And virtual IBC are smart contracts which implements the IBC spec in Solidity. And it offers the same functionality as IBC does in the Cosmos ecosystem. The goal of virtual IBC is to target chains that don't natively implement it. If you're a Cosmos chain, you natively have IBC kind of in your chain implementation. You're able to communicate cross-chain between different protocols in the Cosmos ecosystem. What VIBC does is that it creates an IBC native feature set for non-IBC chains, e.g. Ethereum chains. So if you deploy the virtual IBC contracts on your rollup, you'll be able to communicate with Polymer to then transport, communicate with other chains throughout the kind of connected Polymer ecosystem. So going into some more details about how to visualize Polymer and what your mental model should be about Polymer. A common comparison that we make is to a concept called service meshes. A service mesh is a software layer which handles communication to different services and applications in cloud environments. And so a popular architecture in cloud was microservices. Applications are a set of different microservices that all communicate and interact together in order to create like a full application. You can think of like you have a authorization and authentication microservice, and then you have maybe your your data store service, and you have some, I don't know, execution service, and they're all communicating together to create the full-blown application. And so there's a popular service called Istio, which is a service mesh platform, and it connects all these different microservices and applications to create, broader range applications and across different clouds as well. Polymer, with the help of IBC, is what is establishing this communication protocol and policies among the different components of the Ethereum ecosystem. And so one way to think about it and to visualize it, instead of what we had previously were cloud providers here, AWS, Google Cloud, and then different microservices and applications. In the Ethereum ecosystem, your different components are your L2s, and then there's even now a shift towards more modularism and application-specific L3s. So the comparison here is that Polymer is the Istio of the Ethereum ecosystem, where it is the Polymer is establishing the service mesh for the different components, the L2s and the L3s, to communicate with one another and interoperate very, very seamlessly. So this is a Celestia Hackathon. It's the Infinite Space Bazaar. Where does Celestia fit in here? What is Celestia's connection to Polymer? So OP stack chains are rapidly adopting the migration to Celestia DA for a variety of reasons. It's cheaper, it's faster, and there's a variety of different benefits of just going modular and having more flexibility in your chain architecture. DA is a crucial part of verifying and validating cross-chain transactions. So Polymer's integration of Celestia DA is required to maintain the security of cross-chain transactions. In order to confirm that a transaction is valid from chain A to chain B, Polymer needs to be able to access, just as any other execution environment needs able to access the data that is used in that transaction to either submit fraud proofs or confirm that it's a valid transaction. So this integration ensures that Polymer can integrate and support OP stack chains that utilize Celestia as their DA layer. And so then going into more of the actual bounty. So kind of just explain Polymer's core technology, talked about the connection to Celestia and the migration towards more of a modular ecosystem, which makes interoperability even more important. Now going into, hey, what is this hackathon bounty? What are some of the participants in the hackathon building if they choose to build for the Polymer bounty? So Celestia really introduced this paradigm shift that we're currently undergoing in the Web3 ecosystem towards modularism. As I mentioned before, modular ecosystems, just like microservices, it's extremely important that they have interoperability, right? I think a lot of people talk about the problems with Ethereum right now, of them being fragmented. And a lot of teams are working on the interoperability problem so that that fragmentation is reduced and there's less friction to communicate between chains, which is essentially right now the path towards scalability. The validation of these transactions is a critical component of ensuring interoperability and verification of cross-chain transactions. Yes, you can send messages across chains through, an off-chain relayer, etc. But if that transaction isn't valid, or you're introducing a variety of double spends or security issues, then interoperability is meaningless. And so an important concept to understand is that cross-chain transaction validity comprises of two different steps. You need to have data availability confirmation and then Ethereum verification in this modular ecosystem where you're using a DA solution. And so the goal of this hackathon is to create a server or an IBC-like client that verifies availability of valid data on Celestia DA for L2 transactions, and specifically OP stack L2 transactions. So this is a high-level overview of kind of what the general integration would look like. The server or project would be extracting the L1, it would be retrieving the L1 state root, extracting the L2 state root from that, from the Ethereum L1. Then further in step 2, getting the L2 block associated with that state root, extracting the individual transactions from that block, and then being able to query the blob stream in Celestia for that transaction data to confirm that it is in fact available. You could do even more and say, hey, I want to actually run the DA proof to further ensure validity of that the transaction happened. This is a pretty big lift, especially if you were going to make this hackathon project an IBC-like client. Right now, IBC-like clients are set up to interact with Tendermint, and so you would first need to create an IBC-like client that was able to receive transactions from the OP stack chains, and then be able to integrate Celestia DA, verification of Celestia DA. Josh, did you have a question?
Yeah, I was going to ask, for people who aren't as familiar with IBC-like clients, could you give us a brief explanation of what that is?
Yeah, IBC-like clients is a set of interfaces and specifications to essentially track the state and updates of cross-chain message passing. So you would have like clients on essentially your chain and both chains, and it's used to confirm the state of each chain so that both endpoints of your communication can have the same information that they're working off of to communicate with each other.
Got it. Cool. Thank you.
And yeah, so to that point, like clients and IBC, there's a bunch of work that would need to be done to create those interfaces in order to become integrated with Celestia and the OP stack chains. And so I put this in the Discord channel for Polymer's in the Infinite Space Bazaar server for Polymer, but I tried to break this down in much smaller steps so that it could be feasible in the time period of this hackathon. And so step one is essentially abstracting away the IBC like client aspect of this, and then just creating a server which receives a transaction hash from an OP stack L2. You could think of this, you could create an event listener, you could, index the chain and just say, hey, at every block, extract some transactions, and then check the Celestia chain specifically if they have data associated with that transaction hash. And it would essentially be just returning a Boolean saying, hey, is this DA, does this data for this transaction, does this exist in the Celestia blockchain, would be step one of this. And that would be a really great starting point for, hey, how would you eventually integrate Celestia into Polymer? Then step two, what would kind of, if you get that piece done, what would this next phase look like? To expand on this, the next phase would be then checking the blob stream contract for the proofs associated with the OP stack L2 transactions. So Polymer, as I mentioned, previously in the presentation, it uses Ethereum state it expands the native bridge to really secure all cross-chain transactions. And so also relying on the Ethereum L1 for the essentially source of truth for data availability is the most ideal, and where we'll eventually get to as well when we integrate Celestia DA. And so Celestia currently right now writes the DA proofs to the Ethereum L1 through the blob stream and writes it to the blob stream contract. So instead of checking the Celestia chain directly, you would now be checking the blob stream for the DA proofs. The third step, which would be going one step further, would be now, actually executing the proofs in your server to confirm the validation of the transaction and that it existed. And so this is adds a little more complexity. You would have to understand some concepts about Celestia and how to execute proofs. But then that would add even another level of security and verification for transaction validation in your application. And then last but not least, if you did want to tie it all together and implement an actual IBC-like client, which implements Celestia DA, I posted a bunch of documentation on this at the end of the presentation, but you would essentially be implementing 4 main interfaces. You would have to understand what client state was, you would define your client state, your consensus state, what a client message looked like to update your client state and your consensus state, and then your overall client module, which kind of controls all of the communication from your chains and updates the state of the client itself. So you would create this IBC client interface, which utilizes Celestia DA to provide interoperability to these Ethereum rollups. I think any one of these steps would be really interesting and useful. Just being able to connect and verify information on Celestia would enable a lot of new features and technology to be used in the interop space. And so this is just some basic pseudocode I wrote that was kind of walking through hey, what would the steps look like from an implementation standpoint that you would need to create this or define this. And so right in your server, you could do something about these right here. This is getting the state root, extracting the block information, then getting the transactions from the blocks, figuring out your connection to the Celestia client, going through all the transactions in the block, decoding that transaction, and then having some function that says, hey, is this valid or not? And at the most basic level, that verification could be, is the data available or not for this transaction? And then in maybe the more robust and mature version could be, hey, given this data associated with this transaction, can we execute the proofs? IBC fan, yeah, great question. So I believe the transaction information, that is part of the hackathon, I think, will be figuring out what the best mapping from Celestia blob to L2 transaction will be. I think what you might need to do is, for a L2 that utilizes Celestia, is track the original DA commitment from the L2, but there could be a variety of different solutions there of how you extract or how you map the L2 transactions to the Celestia DA blob. But that is definitely a key component of this, right? Let's see, what step would it be in? Yeah, so this line here, transaction data equals await Celestia client get data transaction by hash. Figuring out the logic that would be in there to create that mapping is pretty critical to accomplishing this this hackathon bounty.
I think part of like that mapping, the transaction itself would actually probably be within
The
a
block.
rollup block itself.
Yeah.
So like one L2 transaction might correspond to a blob that is attesting to like a batch of transactions or a batch of blocks on the rollup itself.
Yeah. So to that point, right? Like, I think, Josh, what you just mentioned was right. There might not be a one-to-one mapping.
Yeah.
Because there might be, right, a blob might be associated with proofs associated with a batch of transactions. And so determining that mapping is definitely like novel work to understand and to be able to accomplish this for sure. But definitely really interesting. Yeah, I would say really interesting research. And then, so yeah, like right here is some tutorials on IBC, as well as, one of my colleagues, Mav, is prolific in writing, talks a lot about interoperability and kind of IBC in general, but has a bunch of good information here. The Polymer white paper, which goes into much further detail about Polymer and some different blogs that we have, as well as kind of, I believe these are the Celestia Blobstream blog and specs, which kind of is probably a really good place to start if you're kind of looking into that question that IBC fan had about how do you establish these mappings. But yeah, thanks for listening in, guys. But yeah, would like to open up to any questions, or can discuss like maybe more details about like, what people are building. Would love to open this up.
I don't see any in the chat yet. I'm going to go ahead and ask a few that I wrote down during your presentation. I'm curious if Polymer can be used between not only like L2s, but L3s, or would Polymer itself need to be like deployed onto L2s to be then used on an L3?
Yeah, great question. So right now, Polymer supports only OP stack L2s.
Cool.
I think once there is significant like exit velocity or enough L3s where like interoperability is starts becoming kind of an issue,
Yeah.
fragmentation starts becoming an issue, we plan to expand to L3s. But right now, yeah, it's currently focused on L2s, but I think the process of expansion would be, L2s support beyond OP stack L2s, L3s, and then beyond the Ethereum ecosystem. Can you connect like, Ethereum chains to Cosmos chains and any other ecosystem as well?
Nice. And I guess on that note, I'm also curious, can I use Polymer between L2 that uses Ethereum for DA and between one of Ethereum DA L2 and a Celestia DA L2?
So that's definitely what we're trying to get to. Like right now, the Celestia integration is not fully done, but yes, because going back to like my presentation, maybe. So here, right, essentially, let's say this, maybe go back even further. Let's say rollup A used Ethereum SDA and rollup B used Celestia. Polymer would be reading the state from the L1, but instead of the kind of Ethereum DA,
Yeah.
it would be reading from the Celestia DA on rollup B in order to do it. So in theory, yes, like that would be completely any sort of DA actually that's settled to Ethereum, we would be we'd be integrated with, so that we could connect Celestia teams that use Celestia DA, teams that use Ethereum DA, or even chains that use any other DA solution that could all communicate with each other.
For sure. And I guess I'm curious if you want to maybe go more into the bounties. And like secondary question to that is, what are some things that you'd like to see built with Polymer?
Yeah, so the bounty I believe is for 10K, and essentially I think you can think of it as two ends, but right, kind of to IBC fans' question, it's like first, it's like, hey, I think the biggest thing, even with step one, and why I tried to break the problem down even further, there is already some complexities of mapping individual transactions to kind of to select, like, how do you confirm that on Celestia? And so I think you can take one angle of like, hey, do we start basically a very Ethereum OP stack, a very Ethereum focused approach at the beginning and say, hey, can we just confirm that we have the data for a specific transaction hash? So that would be, I think, one angle, and like keep building out from there is kind of what I've outlined in this presentation. And then the other angle is to take more of the IBC native approach and kind of work from the other way. Start with, the light client and say, hey, can we create a light client that essentially can communicate with Celestia? And then from there, you kind of work the other way around. Okay, can communicate with Celestia. Now, if this light client can also receive, transactions from the OP stack, and then you can build it kind of back the other way, are, I would say, the two main approaches. But anything that kind of, I think, on one side enabled, right, data availability confirmation of individual transactions would be like a really, really big, I think, milestone and really interesting problem to solve. And then on the other end, anything related to advancing and extending the functionality of light clients to be able to interact with Celestia would also be like another great thing to see built.
Awesome. I actually don't have any more questions, except for maybe if there's anything else you'd like to share about Polymer. We have some time. And then what's the best place for people to reach out?
Yeah.
There we go.
Yeah.
Nice.
So definitely if you're here, right, I think the main place of communication that kind of the Polymer community and our team is on Discord. So definitely like join our Discord server. There's a lot of activity going on there. We are going into phase 2 of our testnet next week, where we'll be launching a really interesting application that will kind of stress test our network, stress test developers, etc. And so we're really excited about that. Definitely check out the Polymer GitHub. We have a lot of really interesting projects on there, both from an infrastructure level. There's a bunch of kind of template code and starter code to develop applications, as well as a really large library of community built applications. And then, of course, follow our Twitter as well. And then down below is my personal information, both on Telegram and on Twitter. Definitely feel free to reach out. Would love to talk about Polymer in general, or if you want to discuss this bounty specifically, definitely we're here to hop on and help any of the builders get this done.
Awesome. I guess, like, thinking back, I am a little curious, maybe if you want to go a little deeper into it, about how there haven't been any exploits using IBC and like why this is the case, but also if there is any attack vector where an exploit could happen, or is it really just that secure?
Yeah, no, it is a great question. So maybe I'll go in like reverse order of how you, in terms of like attack vectors. Actually, my previous background is mostly in the Ethereum ecosystem, and then I worked at Near for a couple of years. So I was not in kind of the Cosmos IBC ecosystem. And so I don't have enough intimate knowledge to understand, like, hey, are there any potential attack vectors? But I do think kind of these numbers are pretty impressive and speak for itself, right?
Yeah.
And so I think there's probably a bunch of technical, there's a bunch of deep technical information about, like, hey, what are potential attack vectors? Why haven't they been exploited? But, Cosmos itself is a pretty large ecosystem. There is, I believe, now over 1 billion cross-chain transactions that have occurred.
Wow.
So it's like not like it's like there's been zero exploits because there's zero usage.
Right.
It's used, but there hasn't been zero exploit. I think from a fundamental standpoint, the security really comes down to this kind of concept of acknowledgement at the most simple level, right? So a lot of times, right, in cross-chain communication and asynchronous processing, right, if you have a send, there could be a failure over the course of the life cycle of that send, or at the destination, and then that causes an exploit. A lot of these bridges, it was getting drained because there was like a transaction being exploited in a contract either on the source or the destination. But when you have this concept of having it be acknowledged, there's no way to like just send a transaction out and have it go into like the abyss. And if there's a security exploit, it can kind of like iteratively run it and either keep draining it or keep exploiting the security vulnerability. And so that acknowledgement, I think, has really kind of hardened the security overall. And yeah, the proof is kind of in the pudding of kind of how it's been able to perform over a pretty long period of time. And yeah, I think it takes, right, there's more logic associated now with a transaction. So in terms of like performance, right, you now not only have to deal with actually sending it, but the acknowledgement. But I do think the security trade-offs, the performance security trade-offs, are beneficial to essentially ensure that there won't be any exploits. And one of the reasons, I think one of the secure design principles around Polymer was really enamored by the technology about IBC, the resilience, maturity, and stability of it. I believe the spec hasn't changed. Like the core IBC spec hasn't really changed since basically the beginning. And so was very thoughtfully designed and has been proven to be very robust as well.
Cool. And I guess, yeah, as someone who's used IBC, but also used like bridging between different Ethereum, like EVM chains, it always continues to blow my mind a little bit when I do an IBC transfer or an IBC swap or something, because you don't have to really wait on it nearly as long, and it just tends to work.
Yeah. I think definitely right, IBC Cosmos, it was designed with that principle as like kind of like a guiding principle of the ecosystem, whereas now I think others are starting to try to adopt it. But yeah, I think kind of the design of the different L1 protocols, underlying protocols, kind of create that UX difference that you're seeing when you're doing a Cosmos transfer versus like a bridge transfer or anything like that.
For sure. Well, thank you again, Ken, for sharing everything about Polymer with us and teaching us some things as well. If there are no more questions, we're going to go ahead and end the stream, but I wanted to know if you had any last words or anything to remind us about again.
Yeah, no, just thank you for having me on. Definitely really appreciate it and excited to see what everyone builds. Yeah, definitely feel free to reach out. As I said before, excited to see all the submissions.
Awesome. Thank you again, everyone, for attending. Thank you, Ken, once again, and have a good Friday and a nice weekend.
Thanks, Josh.
You're welcome.